Hi everyone, this is Siddharth and thank you so much for watching The Diligent Educator. So finally we are here with our first educational video and the topic for today is the basics of electronics. So before starting with the main topic of electronics, let me just give you a brief idea about atoms. So every material, every substance existing in our nature is made up of small indivisible particles called as atoms. Now every atom is made up of subatomic particles which are protons, neutrons and electrons. Now the topic of interest for today is electrons. So electrons, which are present in every substance, are negatively charged. So they are a charged body and they have negative charge on them. So in today's topic we'll talk about electric current. So let's just try to break the word electric current. As we all know, the word current means flow. Like you must have heard about water currents. That is when water flows. So this is electric current. So what is going to flow over here is electrons. So is it like the electrons can flow in any random direction and we'll call it as electric current? No. You will need a unidirectional flow. You will need a unidirectional flow to call it as electric current. So how does that happen? Let's see. Consider this as a conductor. Now in a conductor, as I told you, it will be filled with atoms. We'll talk about atoms afterwards. But for now, our interest is in the electrons. So these are electrons. Now electrons are always in the state of random motion. All the electrons, they are running here and there in the conductor. Now since they are in the state of random motion, they are equivalent or net electric current produced because of them is zero. But if I apply, now this is very important thing over here. If I apply an energy source, I'm talking about a cell over here. If I apply a cell over here, all these electrons, they will start flowing in one direction. Now you tell me, electrons are negatively charged and this is a positive terminal, this is a negative terminal of a cell. What you see over here is a symbol of cell. We'll talk about the symbols in some time, but this is a cell, this is the positive terminal, this is a negative terminal, and electrons, as I said, is negative in charge. Now as we all know that opposite charges attract each other, so these negative electrons will be attracted towards the terminal that is connected to the positive terminal of the battery or the cell. So all these electrons, they will start flowing from the right to the left direction. Now since all the electrons, they are flowing in one direction, in unidirection, this will constitute to electric current. So let's talk about the direction of electric current. Now you can clearly see over here, the direction of electric current is going in this way, which is the anti-clockwise direction. But the direction of conventional current is always assumed to be going from the positive terminal of the battery to the negative terminal. So if I have to draw the direction of conventional current, which we will always draw in the circuit diagram, it will always be from the positive terminal to the negative terminal of the cell or the battery. By the way, battery is nothing but a series combination of cells. Okay, so let's go ahead. The substance that allows the flow of electricity through it itself is called as a conductor, or as we all know, good conductor. And the substance that do not allow the flow of electricity through itself is called as a bad conductor, or more appropriately it is called as an insulator. So examples of conductor could be any metals like iron, copper, aluminium, and examples of non-metals will go under the insulators, which would be rubber, plastic, etc. So that brings us to a very interesting question. Why are the wires in our houses coated with a rubber or a plastic? So the reason is quite obvious over here, because the wires inside, which are made up of metals, are good conductor. They are going to carry electricity. And the coating which is done of insulator is because so that if we touch that particular wire, we should not get a fatal shock. Having said that, electric current is denoted by capital I, and the unit of electric current, to measure, we always need a unit for every physical quantity. So to measure electric current, we use the unit ampere, which is denoted as capital A. Okay, so now what we understand over here is that the electrons which were earlier in random state of motion are now flowing in some particular direction, in a unidirection, right? And that is because there is some energy which is given to the circuit or the conductor, in this case by this battery. And this energy which is given by this cell is called as the potential difference. And this potential difference is denoted by alphabet V and the units is volts. So we have understood that current is denoted by capital I, units is ampere, and potential difference is denoted by V, and the unit is volts. Now let's talk about another very important parameter which comes into the picture when we talk about the basics, and that is resistance. Now resistance, as the word says, means opposition. Opposition to what? Opposition to the flow of electrons. Now the electrons which are flowing in the conductor, which constitutes to the current electricity or electric current, what exactly is opposing the flow? If you remember, I told you every conductor is made up of atoms. Now atoms which are quite big in size compared to the electrons, when the electrons are flowing in the conductor, they hit the atoms. And while they are flowing, when they hit that particular parameter of the conductor is called as resistance or the opposition. Now this resistance is denoted by capital R, and it has a unit. Now look at this denotation of the unit. It is denoted by a Greek alphabet called as omega. The unit is called ohms. So ohm is the unit, but it is denoted by Greek alphabet. This is the capital omega which we are using over here for the denotation of resistance. Now it is quite clear from this particular thing that good conductors will have low resistance and insulators are going to have very high resistance. A small analogy which I can give you, which will help you understand resistance very well, because we are going to take forward this particular topic in our further videos as well. Now suppose you are traveling on a bridge, a railway bridge, you are crossing it, you are walking over a railway bridge, and there is lot of crowd. There are many people standing over here, and you saw your train is just arriving on the platform. You start to run. Now when you are running, obviously you know everyone will not give you the way. You will be dashing with people, you will be pushing them, they will be pushing you. So what you are experiencing is the opposition. Same way, what the electron is experiencing is the opposition, which in electronics terms will be called as resistance. Now so far and so forth, we have talked about current I, potential difference V, and resistance R. All these three parameters are closely related to each other, and there is a law which relates them together called as Ohm's law. So we'll talk about Ohm's law in our next video. Thank you so much for watching the video. Do like, comment, share and subscribe to my channel, and let your friends know about this channel which I have started. Thank you so much.